Welcome everybody to today's demonstration. My name is Jonathan Asher, the Catia Construction Portfolio Director, and today we're going to look at a demonstration for generative and parametric facade design for manufacturing and assembly. We're going to start the demonstration with this, a look at Catia's surface volumetric and solid modeling capabilities. Catia doesn't need much of an introduction here. It's magnificent surface modeler. And here we're showing the parametric methods for modeling different surface types. We made sweeps, we made fills, we made extrudes. Here we're going to make a volumetric extrude, and because it's a parametric modeler, we're going to link the height of the extrusion to a plane. When you update the plane geometry, that extrusion is going to update too. This represents and shows quite clearly the hierarchical dependencies between geometry that are kept within the model. Here's another example. We're going to offset a curve and link an extrude to that offset curve, and when we want to change that offset curve, the extrude is going to follow suit. So this is one example of how to model in Catia to maintain parametric relationships between geometric elements. And we're doing that in this case for a building massing. So we're laying out the initial massing of a building, and we're going to use that massing to create different facades. Next, we're going to look at our first parametric facade design feature, and this is called the variable curtain wall. This is a very powerful patterning tool that allows anybody, a facade designer, engineer, or just architectural designer, to select any surface in their model and start to lay out a curtain wall pattern. There's a number of very powerful features in this command that allows you to control spacing, horizontal spacing, vertical spacing. You can add reference planes to create what we call bands. And then you have control over the opacity, the color, and these framing elements. So you can change the mullion sizes. You can add louvers. You can do all kinds of very powerful things with this variable curtain wall feature. It produces not just the pattern, but the geometry, the wireframe geometry as well. Next, we're going to look at a second type of command. This is called panel wall. And panel wall is a way of instantiating panels that are coming from a catalog or coming from a more manufacturing perspective. So in this case, we've designed parametric panels that are based on simple surface geometry. And inside those panels, a number of parameters have been exposed. Parameters that control the width and the height. And so when we're laying out these panels here, you see we get a pattern dynamically showing up on our surface that we're going to be panelizing. And then automatically we can instantiate those parametric Catia components onto our facade using surfaces as references. And all the while, this is done automatically with the panel wall command. The pattern is generatively generated. The instantiation is automatic at the click of a button. And in this way, we can instantiate detailed components with the click of a button. And so this is the second example. The third example we're going to look at is a generative approach using an application called Generative Design. So here we've extracted one surface from our model, and we've opened it in Generative Design. This is a web application that runs on your dashboard. There's no software to install to run this application. And we're going to start by making a couple of reference planes. These planes are going to form the basis of our facade pattern. And so here we're cutting the horizontal planes. And from there we're going to create surfaces to represent the slab, just so we have a better reference, visual reference for our facade design. We'll thicken those surfaces, and then we'll do an offset of that surface for our face of glass. From there, we're going to make another intersection, and then we'll divide those lines to represent our panel widths. And as you see here, Generative Design is both an interactive and a graphical scripting application. So in this case, you saw us modeling interactively in 3D, but all the while we were producing this graphical script in the background. And at any point, you can open up that graphical script and continue editing it, making modifications to it, increasing or modifying the logic, or go back to the 3D and keep working in 3D. So now that we have a panel pattern, we've panelized our facade. We've exposed a number of parameters here that are control parameters. So we've exposed we've declared our panel width, or number of panels in the width as a driving parameter. And when we go back to the rich client here, our master model, we have that parametric facade panel pattern, in our model. And those parameters that we defined in XGenerative Design are exposed here as control parameters. So we can continue to modify and work on our model in this context. Next, we've gone through the process of modeling two different parametric panel components. These are detailed unitized curtain wall panels with the mullion extrusions, and each one of those panels has a drawing. These panels are based on 4 input points. So regardless of how those input points, the geometry of those input points, the panel geometry is going to update. We give those panels a name, and what we see here is how that panel is added to what's called an engineering template. Here we're declaring those 4 points as our inputs. And this engineering template now is going to be saved to the database and accessible to be instantiated into any other model. Finally, we're going to create an object type. We're going to insert that engineering template into our object type. And in this way, we're going to be able to use a mechanism called component-based design to do that automatic instantiation. Of course, save the model, go back to our context model. And here we're going to select those inputs. And this is called define specification. We're going to assign that curtain wall panel that we just saw to the pattern that we developed in XGenerative Design. And here you see we're defining those inputs. We're going to do it by a list, so that way we don't have to instantiate one by one. We can instantiate any number of panels. And as we get into the demo, you see we're going to instantiate 6 panels initially to see how those fit on our facade. We're navigating through the compass to change applications. You see the Catia roles for construction are very rich roles that contain a number of applications. Those applications are accessible at any time through the compass. So by activating the compass, you can switch between applications that come in your individual roles. Now back in the model, we've changed LOD. We've changed level of development, and we've instantiated 6 engineering templates into our model. And you see that the geometry of each one of those panels is updated based on the location of those 4 input points. And again, the drawings are dynamic. The drawings will update based on that new geometry. And that includes our bill of materials with all of our length dimensions. And the other thing that's important here is those extrusions are all solid geometry that can individually be exported as step to run any CNC machine. Now we're going to change just this panel object here and say we're going to instantiate that second panel that has a little pyramid pop out. So we've selected that panel. We'll go back to our change level of development, instantiate that pyramid panel, and here it is in the model. So in this way, you see there's a very interactive and intuitive way to take these parametric components and instantiate them into your model. And at any point, the parameters that drive those panels are accessible through this interface and can be manipulated and modified. And of course, those modifications are going to be reflected in the drawing. Next, these panels aren't floating in space, they're anchored. And so we've got this halfin anchor, this halfin embed that's connected to our serrated anchor. And so we're going to use the same mechanism to instantiate that anchor into our model. We're not showing the actual Catia methodology or the solid modeling of any of these components, but those follow the typical parametric Catia modeling methodology that you'll find in say part design or generative shape design. It's all very standard Catia solid modeling. Next, so we've instantiated this one halfin into the model. And now we're going to make an assembly pattern. And this assembly pattern is going to take that same typical halfin embed plus our bent plate anchor, and it's just going to pattern it to every location where we've specified an anchor should be placed. And we've specified those locations with axis systems in X Generative Design. One really powerful aspect of this modeling workflow is that we've identified and we've specified protected zones for that anchor. And when that protected zone comes in contact with a facade panel, it's going to Boolean out the location of that anchor from the extrusion. And that means that the extrusion is going to include then the required holes for milling when it's eventually manufactured. And you see the detailed view of that. At any point, we can section the model to interrogate the geometry and make sure that it has been properly modeled to exact geometric precision. In Catia, we're modeling to the micrometer if you prefer to model to that level of precision. Next, to show the parametric nature of this model, let's go back to the parameters that we defined to control the pattern in X Generative Design and show that all of those parametric relationships are maintained. So by changing the width parameter, the number of panel parameter for this facade, updating the model is going to update the pattern and relocate those panels to their correct location. So that's the generative and parametric facade design. Taking this a step further, we're going to select this face, this entire face, so the pattern plus the panels, and we're going to replicate this onto the two other faces of the model. We're power copying one facade to the other facade, and it's an incredibly powerful way to define the specification of the facade on one face and then replicate that to other areas of the building. Going back to the massing, we see that this parametric model remains a parametric model throughout its entire life cycle. So at any point, we can go back to the original surface design. We can modify the angle of that line, which is going to update the surface geometry, and it's going to in turn trickle down and update the pattern geometry and those detailed engineering template facade panels that have been instantiated in the model. And of course, everything is going to update with it. It's one big parametric system. One other example here to show finally where this has been put in place on another project. This is a large tower where you see we've got this interesting patterning of a tower facade in X Generative Design that's based on images, black and white images of smoke. We've got 10 panel types of that pyramid facade panel that are all based on the pattern. And then flicking through, I think we have 6 different images in our X Generative Design model. As we flip through those 6 different images, that layout of those 10 different panel types is going to update, and here we see the result of that. Thank you very much for your attention. I hope you've enjoyed this demonstration. If you have any questions, please post them in the comment section and we'll be happy to respond. And as always, don't forget to like and subscribe.